In Chapter 5.2, we looked at the multiplication and division of rational expressions. Here in 5.3, we're going to look at the addition and subtraction of rational expressions. And I'm going to give you a brief example of how this works by going back to an old subtraction of fractions problem. We have 5/6 minus 4/9. What we needed to do was find a common denominator in order to do that subtraction. But what we're going to do in this particular case is we're going to break the denominators down into its prime factors. In the first case, it's 5 over 3 times 2. In the second case, it's 4 over 3 times 3. Now we do have one prime factor that's common to both, and that's the 3. It's one here, and there's one here. However, in the first fraction, we are missing another 3, and in the second fraction, we're missing a 2. So what we do here is we take and multiply 5 over 3 times 2 times what's missing, which is 3 over 3. And then we take the second one, 4 over 3 times 3, and we multiply that by the fraction 2 over 2. What that gives us is the same denominator, 3 times 2 times 3. 3 times 2 being 6 times 3 is 18. Now our first fraction, what we have is 5 times 3, which is 15, over 3 times 2 times 3, which is 18, minus 4 times 2, which is 8, over 3 times 3 times 2, which is also 18. And now when we subtract, what we're going to get is 7 over 18. Now that's not the way you solved the addition and subtraction of fractions before. You probably didn't break your denominator down into prime factors and those kinds of things. But the rationale is the same. Once we do that, we find out what's missing, and then we multiply by that, both in the numerator and the denominator. If you notice, what we multiplied our first fraction by was that 3 over 3, and the second one was the 2 over 2. So, let's just quickly review some of the things that we need to know about addition and subtraction of fractions. If we have a common denominator like we do in number 16, now all we have to do is add the numerators, 5 plus 11, over that common denominator, 4CD. And what we get is 16 over 4CD. But we can reduce that down because the 4 and the 16 will cancel, and we get 4 over CD. In our second one, number 32, we still have a common denominator, a squared minus 8a plus 15. So we don't have to rationalize anything like we did in our example. All we need to do is take our numerator, 5a minus 12, minus the quantity, 3a minus 2. Notice I put that in parentheses, and that's over our common denominator, a squared minus 8a plus 15. Then when we combine those, we have 5a minus 12 minus 3a plus 2 over a squared minus 8a plus 15. When we combine like terms, we have a 5a minus 3a, that's 2a. And we have a negative 12, positive 2, that makes negative 10, over a squared minus 8a plus 15. Now what we can do is we can factor that numerator. 2a minus 10 becomes 2 times the quantity, a minus 5. And we can factor our denominator, and a squared minus 8a plus 15. What two numbers multiplied together give us 15, the sum of which is negative 8. And that turns out to be a minus 5 times a minus 3. And now we have in both the numerator and the denominator a factor a minus 5. So when we cancel those out, we get 2 over a minus 3. So that's the way we work with those if we have common denominators, but let's take a look at some if we don't have common denominators. Taking a look at number 48, for example, the denominators are x and 3. So what we need to do with our first term then, our common denominator will be the combination of those two, 3x. So we take that first one, 5 over x times 3 over 3, which is the equivalent of 1, plus 2 over 3, and what we need here is x over x. Now what we get is 15 plus 2x over 3x. X times 3, 3x. And if you want to write that appropriately, it would be 2x plus 15 over 3x. Now it'd be nice if you thought you could cancel someplace, but you really can't, because you can't cancel the x's. You have to have the x in both terms in order to cancel that out, which we don't. We can't cancel the 3 with the 15 unless we also had some number divisible by 3 in the first term, 2x, and we don't. So basically, with number 48, we are done. 2x plus 15 over 3x. Now in the next one, number 58, you'll notice we do have x terms in both denominators. The numbers 5 and 2, the common denominator there is going to be 10. And because we have x cubed, we just need to add an x to our second term. So what we have in the first term is 4 over 5x cubed. And our common denominator is going to be 10x cubed. So all we have to do is get to the highest power. So what we need to do here is just multiply by 2 over 2. Then we have minus 3 over 2x squared. And here, to get to 10x cubed, we're going to have to multiply, both the numerator and denominator by 5x. What that gives us now is 2 times 4, 4 times 2 is 8 over 10x cubed minus 3 times 5, 15x over 10x cubed, which gives us 8 minus 15x over 10x cubed. And unfortunately, again, there's no way to reduce that down to lower terms, so that's our answer. With number 66, our common denominator is going to be x plus 2 times the x. So what we need to do here is we need to take that first term, 4 over x plus 2 times x over x. And in the second term, we need to take 3 over x and multiply that by x plus 2 over x plus 2. Now what we get is we get 4x plus 3 times that quantity, x plus 2. And that's key. Got to remember, you're multiplying that 3 times that whole quantity, x plus 2. And our denominator now is x times x plus 2. In our numerator, we get 4x plus 3x plus 6 all over x times x plus 2. We can combine those like terms and we get 4x plus 3x gives us 7x plus 6 over x times x plus 2. Now we weren't able to reduce those down to anything more simple than that, but at least we were able to combine those. And so if you understand that, you understand the process. Now we want to look at some that are just a little bit more challenging here. What we have is two binomials in the denominator, x plus 4 and x minus 1. And so in this particular case, our common denominator is going to have to be that first binomial, x plus 4, times the second binomial, x minus 1. And to get there, we're going to have to take 5 over x plus 4 and multiply that by x minus 1 over x minus 1. And then from that, we're going to subtract 3 over x minus 1 times x plus 4 over x plus 4. In our first term, then, we're going to have 5 times the quantity x minus 1. And then minus 3 times the quantity x plus 4. And our denominator now is going to be those two binomials, x plus 4 times x minus 1. You'll notice that I combine them that way. If you wanted to combine them x minus 1 times x plus 4, you're more than welcome to do that. So now when we multiply across in our numerator, we get 5x minus 5 minus 3x minus 12 all over x plus 4 times x minus 1. You know, it would be nice if you could kind of shortcut some of these processes and not do all this writing, save yourself some lead, pencil, and time. But you just really can't do that. You need to write all the steps, because that not doing so leads to errors. I mean, you can make errors without shortcutting, but when I take my like terms of 5x minus 3x, I get 2x. And my like terms minus 5 and minus 12, I get minus 17. And then I get x plus 4 times x minus 1. And that's as simple as number 72 gets. Pretty complicated answer for all that work, but that's the system. When we look at number 84, now in the denominator of that first fraction, we actually have a perfect square minus a perfect square. So I'm going to rewrite that as a over a plus 1 times a minus 1 minus 4 over a minus 1. So now, because we have an a minus 1 in both locations, here and here, what we're able to do is make our common denominator just the a plus 1 times the a minus 1. That means in our first fraction, a over a plus 1 times a minus 1, we don't need to do any work. In the second one, we have 4 over a minus 1. We need to multiply that by a plus 1 over a plus 1. What that gives us now is a minus 4 times the quantity a plus 1 over a plus 1 times a minus 1. That's equal to a minus 4a minus 4 over a plus 1 times a minus 1. When we combine like terms, what we get now is minus 3a minus 4 over a plus 1 times a minus 1. And unfortunately, we're not able to factor that numerator, so we can't reduce that down anymore. We have just one more problem we want to take a look at, And that's on the next page, problem number 102, because it involves both addition and subtraction. So we're going to go ahead and scroll back up. We'll erase a few, and we're going to take a look at 102. It's the most complicated problem we've got. You can do 102 or problems similar to 102, then you understand how to add and subtract rational expressions. So let's erase all this, copy down problem 102, and we will be done with this particular lesson. Sorry it's taking me a little bit of time to erase all this. There's so much work that goes on in these things. Anyhow, problem number 102 involves both addition and subtraction. And unlike multiplication and division, you need to take these sort of one step at a time. But we have 1 over p plus 1. And then plus 1 over p plus 3. I'm sorry, that's p minus 3. Make sure we get that correct. P minus 3. Minus 4 over p squared minus 2p minus 3. Now in this particular case, what we're going to do is factor that trinomial in the third term. And so we'll copy everything else down again. Plus 1 plus 1 over p minus 3 minus 4 over. And when we factor that, what two numbers multiplied together give us minus 3, the difference of which is minus 2. What we get is p minus 3 times p plus 1. Now by factoring that, what we notice is that in the denominator of that third one, we have the denominator of the first and the denominator of the second. That makes things a little simpler. That's why we decided to factor that trinomial in the third term. So our common denominator will be p minus 3 times p plus 1. In the first one, what we'll do now is put 1 over p plus 1 times p minus 3 over p minus 3. To that, we're going to add 1 over p minus 3 times p plus 1 over p plus 1. And finally, we're subtracting 4 over p minus 3 times p plus 1. So now we have our common denominator all the way through. And when I multiply 1 times p plus 3, what I get is p minus 3. P minus 3 over p plus 1 times p minus 3. Then I add p plus 1 over our common denominator. And I'm going to reverse the order there. I'm going to put it p plus 1 times p minus 3. And then I'm going to subtract 4 over, and I'll rewrite that denominator because I'm allowed to do that, as p plus 1 times p minus 3. That way my common denominator looks the same. Now what I can do is I can start to combine all those terms. I've got p minus 3 plus that quantity, p plus 1 minus 4 over our common denominator, which happens to be p plus 1 times p minus 3. That then becomes p minus 3 plus p plus 1 minus 4. Again, all over p plus 1 times p minus 3. Combining the like terms, p plus p is 2p. Negative 3 plus 1, negative 4. Negative 3 plus 1 makes it negative 2. Negative 2 and negative 4 makes it negative 6. over p plus 1 times p minus 3. For the first time, we can factor that numerator, and we'll factor out a 2, so we have p minus 3. And in our denominator, we have p plus 1 times p minus 3. Now we do have a common factor for both the numerator and the denominator, and so what we can do is cancel those two out, and we end up with 2 over p plus 1. I realize this is a lot of work to get something that really doesn't have a lot of meaning. It's more the rigor of following the rules and going step by step. I strongly recommend that you not try to shortcut anything, otherwise you'll run into a lot of difficulty.